Hi guys, welcome to video lecture number 1. This video covers the first 2 learning objectives of our unit on atoms, and we have 2 essential questions that we want to address. The first is, what is an atom? And the second is, what are the subatomic particles that compose an atom? In other words, what are atoms themselves made up of? Most of you remember that matter is anything that takes up space and has mass, or can be weighed. But my favorite definition of matter is simply stuff. If you can see it, taste it, touch it, or smell it, it is matter. And all matter everywhere is made up of atoms. Atoms are the basic building blocks of matter. Legos are a popular toy in my house. I step on them all the time. And they're a good way to think about atoms, too. Imagine for a moment that everything in the world, the chair you're sitting in, the pencil you're holding in your hand, is made up of teeny tiny Lego blocks. If you can do that, then you're beginning to understand what atoms are like. Another common way of thinking about atoms is thinking of them as these small, round particles. When you look at these Mickey Mouse molecules, right away most of you will probably think of water, or H2O. Water is a molecule that's made up of 3 atoms, 2 hydrogen atoms and 1 oxygen atom. One important thing about atoms of the same element is that they are identical to all other atoms of that element. So for example, even though these hydrogen atoms are part of different water molecules, they are all identical. Atoms are really tiny. In fact, they're so small it's hard to wrap your mind around how small they are. Something that might help is looking at the edge of a piece of paper. As thin as this piece of paper is, it would take millions and millions of atoms stacked side by side to equal the thickness of just one sheet of paper. So of course, we can't see atoms with our eyes. We can't even see atoms with the microscopes that we have in our lab. It takes a super sophisticated microscope called a scanning tunneling microscope to produce images of atoms. And they look quite a bit like the Mickey Mouse water molecules that we saw on the last slide. The crazy thing is that atoms themselves, the building blocks of all matter, are made up of much tinier building blocks called subatomic particles. If we could magnify one atom, we would see that it's made up of even smaller things. The prefix sub means smaller than. So when I use the term subatomic particle, I'm talking about particles that are even smaller than the atoms themselves. It doesn't matter whether we're talking about a carbon atom or a gold atom or a hydrogen atom. All atoms are made up of the same 3 subatomic particles: protons, neutrons, and electrons. Now I'm going to talk about these 3 subatomic particles using 3 properties. Their location, where are they in the atom, their mass, or how do they contribute to the weight of the atom, and their electrical charge. So let's take a closer look at the structure of atoms and the location, mass, and charge of these 3 subatomic particles. We'll begin with location. Every atom has 2 major regions. The first is at the center of the atom. It's called the nucleus. The nucleus is dense, heavy, and it doesn't really move around. The 2 subatomic particles found in the nucleus are protons and neutrons. The second major region surrounds the nucleus and is a lot bigger than the nucleus. It's called the electron cloud, and you guessed it, the subatomic particle that can be found there are electrons. Now, unlike protons and neutrons that make up the nucleus of the atom, electrons are constantly moving around in the electron cloud. They're orbiting the nucleus at incredibly high rates of speed. The second way that we can talk about these subatomic particles is according to their mass. But bear in mind we're talking about tiny things. And so it doesn't make any sense to measure their weight using units like pounds or kilograms or grams. When we do, it gets a little bit silly. For example, the mass of one proton is 0.000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000. It's useless to you, and it's also useless to scientists. So scientists decided, let's make up a new unit of measure for the mass of subatomic particles. We'll call it the atomic mass unit. And let's make it easy for ourselves. Let's say that a proton has a mass of 1 atomic mass unit. I like using the number 1 in calculations. Incidentally, neutrons are almost exactly the same size as protons. So protons and neutrons both have a mass of 1 AMU. Electrons are much, much smaller. Their mass is only a tiny fraction of 1 AMU, which is already such a tiny number that really the mass of an electron is insignificant. We don't count their weight towards the weight of the atom. The only thing that determines the weight of an atom is its nucleus, or the number of protons and neutrons in the atom. Think of it this way. If I was to weigh myself on a bathroom scale, it would really not matter whether I weighed myself with my wedding band on or not. I weigh about 200 pounds, and the weight of this ring won't really determine how much I weigh on the scale. It's the same way with electrons. They just don't really count towards the weight of the atom. Now remember, I did say that the electron cloud is much bigger than the nucleus, and that's a bit of an understatement. The model that you have on your screen is not to scale. If the nucleus of an atom were the size of a grape, then the electron cloud would be more than a mile wide. The closest electrons would be at least a mile away. And so even though electrons are tiny, they occupy a region that makes up the vast majority of the atom's volume. The weird thing about that is that it means that matter and atoms are mostly empty space, with all of their weight being in the center, in the nucleus. The third way that we can describe these subatomic particles is according to their electrical charge. Your first lab in this class will have to do with electrical charges, but for now we can say that protons have an electrical charge of +1, neutrons have no charge or are neutral. If something doesn't have a charge, it is said to be neutral, which sounds a lot like neutron. So neutrons have no charge, and electrons have a charge of -1. Now, electrical charge is really very important. It's what keeps the atom together. And I'd like to leave you with kind of an analogy to think about atoms with. Atoms are kind of like our solar system. Our solar system has the sun at its center. That's like the dense nucleus of an atom. And around the sun, planets orbit and stay in their orbit because of gravity, because of the pull of the sun's gravity. It's the same thing with electrical charges. You'll learn that opposite electrical charges, positive and negative charges, attract each other. So because the nucleus has protons, it has a positive electrical charge. And because the electron cloud is full of electrons, it has a negative electrical charge. The two charges attract each other. And so even though electrons are moving at very high speeds, they don't fly off into empty space because the nucleus pulls the electrons towards itself. Now they are traveling fast enough, just like our planets, that they don't fall into the nucleus. They continue to orbit the nucleus at a high speed. Our next video is going to be over atomic number and atomic mass.